This is part 2 video of our final project demonstration, and in our previous video we looked at this diagram. If we're looking at this diagram, we wanted to test basically how well our encryption did on between these two gateways, because that's a very important step in the VPN, and also how our routing tables were working, it's making sure they were working correctly. And the way we did that was just by having a ping sent from this interface over to this interface, so that would allow us to test the encryption and the routing tables. So we saw in that video that our encryption was working correctly, so the next thing we want to do is make a more extensive test. So we created the entire VPN. So we have, right now on this test, we're going to have 4 VMs set up. Even though our diagram shows 6, you don't really need these 2 VMs for the test. So we have the 10.100 Gateway A, Gateway B, and 20.100 VM set up right now. And with the goal, what we're going to try to do is use Telnet to connect the 10.100 computer to essentially shell into the 20.100 computer. And the reason we want to use Telnet is because the ping test is just very simple. The packets aren't that big, so you don't get a variety of packet links to test out your encryption algorithm, make sure it's working correctly. And also the data in the ping packets are very similar, so you're not getting enough. You're not really getting enough test cases just with just the ping test alone. So we're extending it to do Telnet, which should allow us to execute a couple commands over here and just verify that our VPN is working successfully. So if we go ahead and open up this diagram right here, so this is going to be a quick rundown of how our the expected how we expect our program to run, our VPN program. So assume over here is the 10.0.10.100 VM, and it has the Telnet program running on it. And from that program, once we run this command right here, a data packet will be sent from the Telnet program through a TCP port down into the kernel. And once in the kernel is going to look at its routing tables and then append an IP header and a TCP header. And since the IP address and that Telnet's requesting to send it to is in the subdomain of Gateway B, it's just going to go ahead and send this packet through our virtual network interface. And then once the packet's up here in our virtual network interface, the VPN program is going to take the entire packet, headers and all, and just go ahead and encrypt it. And it's going to use the shared key that we discussed in part 1 that the Gateway A and Gateway B shared originally. So then it takes this data, this original packet, encrypts it, and then goes ahead and passes it back to the kernel as a payload for a UDP port. So the routing table go ahead and appends a UDP port and an new IP header. So using that information now, this packet's going to be sent to Gateway B. And so the routing table knows to go ahead and send it out this interface across the internet, and the packet will finally arrive over here on Gateway B. And then inside the kernel on Gateway B, it's going to remove the IP and UDP packet headers, and it's just going to send this entire encrypted data up into the VPN program. And then using the share key, the VPN program on Gateway B is just going to head and decrypt. It's going to take the data and it's going to send it back down to the kernel. And once the kernel is going to look at the original IP address that Telnet asked the packet to be sent to, it's going to take that IP address and it's just going to go ahead and route it down to its subdomain or subnet to this 20.100 computer. So that's how the data gets from 10.100 to 20.100. And this diagram right here is how it gets back. But I'm not going to go over it because it's literally just in reverse, except you'll do the encryption. You'll go ahead and do the encryption on Gateway B and the decryption on point A. So that's what we're going to try to test and verify is working correctly. So just a real quick, we're going to look at this diagram again. It shows how we have our test set up. So over here in this top left corner is going to be your Gateway A. Down here in this bottom left corner, you're going to have your 10.100 VM. This top right corner is going to be your Gateway B, and then your 20.100 VMs will be down here in this bottom right corner. So let's just go ahead and show that. So we see right here, this is a 10.100 IP address, and this is the 20.100. I already have the tunnel set up because I know I want to make this as fast as possible. So the first thing I'm just going to do is just do a ping test to 10.100 and make sure we can connect. We see packets are going through the tunnel as expected. And also, just take note that the encrypted tunnel packets right here, the data size is 96. And hopefully, when we do the telnet on the previous runs, we got much larger packets. But we went ahead and added this to our logging information. And let's going to do one more quick ping test to see if we can access 20.100 from here. So yeah, we see that we're getting the ping package, so we're getting a solid connection. So go ahead and get rid of that. And the next thing I'll do is I'm going to start a Wireshark trace on this virtual interface right here on gateway A. And next, continue without saving. Remove that. Okay. So, and now let's just go ahead and try our telnet command. So okay, yeah. So look here. We see the telnet information coming up here on gateway A. It's like already asking us to log in. So let's go log in. It's asking for the password. We see quite a bit. We'll go ahead and check out the data on the tunnel. So far it's a pretty small package, just 64 bytes. But we successfully logged into 20.100 computer through our tunnel. That's what we've seen here. The next thing we want to do is to see if we can make some larger packet sizes just using some commands. So like I made this file earlier, hello 10.100, so that's the file that can be found on here, over here on 20.100. So we created it right here. So we'll just write something new in it. And then using telnet, we'll go ahead and open it. And usually, like we found that opening VI caused some pretty large packets. I forgot to close it. Well, it didn't seem to be the case here, but in previous runs we had problems with when we tried to open VI, it was causing issues because we didn't have the buffer size of the of our reads or our socket reads set high enough. So that's some adjustments we had to make. So we can see we're now in reading this file on this 20.100 computer. Let's go ahead and write to it and save that. Just now let's go ahead and log out because that's all we really need to verify. And we just see this. So finally, now we just need to make sure our encryption. We saw that our encryption decryption was working okay because the message didn't mess up. But let's just go ahead and verify what kind of security improvements our VPN provides. So as you all know, telnet's still a very bad program to use because it's just ran over TCP. And if we just follow this telnet, this TCP trace, we can see that. So as you can see already, by using this, we're right now we're on gateway A, so the data, it's just we see the password, the login. If you scroll down, you just see essentially everything, all the output from our screen. So definitely not a program that should ever be used anymore. However, our encryption, it works from this gateway A to gateway B. So if we go ahead and look at, actually I forgot to do the Wireshark. So if I go ahead and set up Wireshark on my Mac real quick. And then we go back here and we re-log into that telnet. And we just go ahead and log back out. So if we see, we'll stop this. On the if we didn't use our tunnel, we would be able to sniff the malicious user could just basically just read the TCP stream. But if we go ahead and, however, if our tunnel is being used and someone on the outside won't be able to basically interpret what's happening easily, because this will look like it appears a bunch of UDP packets, so you won't know they're running telnet, and the data will be, the payloads will just be encrypted data, and once again it's just base64 encoded, so it's easier for the network to handle, and it's more readable. So that pretty much verifies that our goal of making that making this little mini VPN right here for the final project, and that's it. Thanks for watching.